Hi, hello, and welcome to Physics Clinic. So, our today's topic is work, energy, and power for class 11 physics, as well as it is more useful for other competitive kind of exams also, especially JEE and NEET. Okay, so this is the chapter 6 of yours NCRT portions, yeah, textbook. Okay. Now, let me explain you about all these things, what are all given. So, in this book, you can understand work done by a constant force, variable force, nature of work, then calculate work done by force displacement graph. Okay. So, from the force displacement graph, we can calculate the work done. Then we can find the work done in a conservative and non-conservative field. These and all you must keep in your mind. So this is our learning objective. Okay. So the reference frame we are going to consider, and then from that reference frame, we can understand the work done, the dependency of the work done. Okay. Then kinetic and potential energy also we are going to see. Okay. Then in a spring, especially in a spring. Okay. Then due to gravity also we need to see in this chapter. Then elastic and inelastic collisions, perfectly inelastic collisions. So this kind of concepts has been taught for you, and then its related problems also very important. Okay, that will be we'll see that. Solve vertical circular motion problems also. So we can solve that. Okay. Vertical circular motion. There are two circular motions. Okay. So one is horizontal circular motion like this, merry-go-round. Another one is vertical circular motion like giant wheel and all. Okay. So we are now going to see that. Okay. So first of all, before getting into that, we must know about the scalar product. Okay, so I've explained about the vectors and how the vectors are resolved. So how it will be characterized in three-dimensional, 1D, 2D, and 3D. So what are all the how we can add the vectors, how we can multiply the vectors. In multiplication, there are two products, dot product and then or scalar product, cross product or vector product. Dot product means the resultant will be the number. Cross product means the resultant also be a vector. Okay, so everything I have discussed about in the video, I will mention that in the description box. Okay, so here we are now going to see the scalar product. Okay, as everyone knows, A and B, this in your textbook, this arrowhead will not be introduced in your textbook since this capital, this block letters, it shows it's a vector. But while you are writing, this block letter is not enough, right? So you need to write like this: A vector dot B vector. Okay, so dot product means its resultant should be actually not a vector. It purely a magnitude. So A dot B is equal to modulus of A vector, modulus of B vector, cos theta, or we can simply write AB cos theta. Okay. So this means we can take either A times B cos theta or B times A cos theta. We can have such a way. Okay. Or A dot B and B dot A if you are taking. So both are same. So scalar product obeys commutative law. So this is commutative law, we know. And then if we talk about the distributive law, so A dot B plus C, that will be A dot B plus A dot C. If you further multiplied any scalar in between, so that will be give you this. Okay. If you multiply scalar, A dot lambda B, you can take out lambda outside. That scalar can be common, a number or a numerical which can be taken outside. As a common, we can keep it. So A dot B will be there. Okay. So we are now, so the proofs of the above equations are left to you as an exercise it is given. You can take it as a proof. What I'm trying to say. You can consider A vector. Okay, A vector is equal to AXI vector. plus AYJ vector. Let me explain about what is I vector, J vector, and K vector. Okay. So in an axis and all, you might have seen X axis and Y axis. So in graphical representation, you have seen what is the graph sheet. Everyone know about the graph sheet. What is a graph sheet? Graph sheet contains the scale of 1 centimeter. Along the x and y axis, you find 1 centimeter as a scale. Right. Similarly, so here also we are going to use the scale in vector plane. It is a vector plane. That is a Cartesian plane. Generally, you are representing in a graph as a Cartesian plane. Here it is a vector plane. Each and every 1 centimeter, instead of that, along the x-axis, it will be I cap. 1 centimeter, 1 unit of x-axis will be considered as I cap. Okay. 1 unit of y-axis will be j cap. 1 unit of z-axis will be k cap. Like a way, so where I cap, j cap, and k cap, this cap represents the unit vector. That means its magnitude will be unity. Get my point? Okay. So what is this 1 centimeter? Instead of that, we can use this as I cap. Suppose if you want to notice this point, okay, this point will be 1 I cap and 2 j cap. Like in Cartesian plane, you can use 1 comma 2, right? 1 in the x-axis and 2 in the y-axis. Like that, here you should add on the vector sign also, I cap and j cap. This is the major difference. I think you get the point, right? So where I, j, k are the unit vectors, you know, and then from this we can understand the dot product, especially the dot product. So here we go. This is ax I cap plus ay j cap if you take it in two-dimensional. Otherwise, if you take it in three-dimensional, it will be k cap also. So we are now getting this like bx I cap plus by j cap. We can take like this. Okay, then c is equal to c vector is equal to cx I cap plus cy j cap. So first of all, you need to add these to b and c. Okay, you are now going to prove left hand side is equal to right hand side because the proofs are left to you as an exercise. So left hand side is equal to right hand side you can take. Okay. So what is the left hand side? So left hand side will be first you can add b plus c. B plus c means you can add only I with I and j with j. So bx plus cx of I cap plus by plus cy of j cap. Okay. So this is b vector plus c vector. Get my point? Okay. Then what is a dot b vector plus c vector? You are going to do dot product with this. So if you do dot product with this, then what is the resultant? I dot I, j dot j, k dot k. Like a way only you can able to get the dot product. I will explain you why. What is the reason? How can you multiply? If you are asked to write about a dot b plus c. What is a? Ax I cap plus ay j cap dot bx plus cx I cap plus by plus cy j cap. Right? So how can you multiply this? You can multiply this first. Right? And then this to this. Then this to this to this. Right? You'll be getting product from I to I and I to j also. So that means I dot I you'll be getting for the first one ax bx plus ax cx I dot I. Next one is plus ax by plus ax cy I dot j. For example, you'll be getting four products. So I will write only two products and I will explain you. If you take this I dot I, what is I dot I? Based on this formula, A dot B is equal to AB cos theta. So here also, modulus of I, modulus of J, I Modulus of I cos theta. So what is the angle between I? Both are I, no. So I means there is no angle. So angle will be 0. What is the magnitude of unit vector? That is 1. What is the magnitude of unit vector? 1. 1 times 1 times. What is cos 0 degree? 1. So 1 times 1 times 1 will be, the whole value will be 1. So bx plus ax cx alone will be there. If you take this for I cross j, I dot j, then what it will be the resultant? I cap, modulus of j cap, and cos 90, right? So what is this I dot j, where I, j are the mutually perpendicular axis? I and j are mutually perpendicular. That means the angle between this is 90 degree. So cos 90 will be 0. So everything becomes 0 here. So I dot j cancel. Okay. So in this particular dot product, only I dot I exists, j dot j exists, k dot k exists. Remaining are zeros. If you want to take a pic or if you want to take a screenshot of this, you can take it. This will be more helpful. Okay. So then we are now going to see about all these unit vectors in a subsequent lesson. I will explain you in detail. So what about this I dot I and j dot j? What we have discussed here, it is given clearly. Okay. And then you know that always if this vector is resolved into two components, okay, then one is cos theta components. This is adjacent side. That and all I've explained more in that video. Okay. So you can look upon that video and come over here. Then it is easy for you to understand. So what about this one? This is opposite side. Okay. So A is the projection of B on A. So this is the meaning. The projection of B on A. Okay. So that means this is B cos theta. So A into B cos theta is the resultant. So the resultant falls on here. Get my point? If projection of A on B means B times A cos theta. Like this. Projection of A on B means B times A cos theta. You know that this is the right angle triangle. It follows trigonometrical rules and ratios. This is adjacent side. This angles opposite will be opposite side. Remaining will be hypotenuse. You know what is cos theta, right? Cos theta will be adjacent by hypotenuse. Hypotenuse are given as B. Adjacent we don't know. So if you want to find the adjacent, so B cos theta will be there. Understood? So opposite will be B sin theta. Like a way we can take. So the projection falls on the adjacent side only. Cos theta components. Okay? So always, so that we can conclude the scalar product as the projection of one vector on the other. Okay? Either it will be, since it is commutative, either it will be A on B or B on A. Okay? I think you get my point. So some examples are discussed over here. You can go through it. Okay, this is very simple. So if A and B are perpendicular, then definitely it will be 0. If it is parallel only, the resultant exists. Okay, you just go through it. Some examples are given. This is a kind of work done. Or you may say projection of F on D. Okay. Then this kinematic equations and all you have learned, right? What are all the equations you have learned? Yes. See, you have encountered all the formulas, right? So what are the formulas of kinematic? So what is the kinematic equations? So when the particle is moving, it is associated with initial velocity, final velocity, displacement, and then it has its own acceleration also. It covers its particular displacement. So everything comprises in a particular time period. So all these parameters involved in deriving the equations of motion, that and all you have learned in chapter 3. From that, this is one of the equations of motion. V square minus u square is equal to 2as. You know that v square is final velocity, u is initial, and a is acceleration, and s is the displacement. Okay. And then out of it, so listen clearly. What is this? V square is equal to, this is the first equation. Now, multiplying both sides by m by 2. If you multiply both sides by m by 2, then what it will be? This 2 and 2 gets cancelled. So it will be m into a into s, right? Here it will be half mv square minus half mu square. What is mass into acceleration? That is the force, according to Newton's second law of motion. So that is force into second law, right? So what is this? V square minus u square, right? So from this, they said again in different dimension. So how we can say if it is equation 6.2 is expressed in three dimensions. Okay, three dimensions means it should be a vector. So a vector dot d vector. Okay, what is a vector dot d vector? If you put, then multiply the same like this, half m by 2. Okay, half m. If you multiply on both sides, it will be f dot d. Okay. So the above equation provides a motivation for the definitions of work and kinetic energy. What is this? Half mv square shows the kinetic energy. That means this v involves final kinetic energy and u involves initial kinetic energy. So there is a difference in kinetic energies. That is, or we may say there is a loss in energy. Okay. Initially, it has one energy, the final energy also there, or it gains some energy. We can say the difference in energy, kinetic energy, is equated to the work done. Okay. So what is the work done? F dot D. So this is a vector. If you want to express it in three-dimensional, you can put it in a vector quantity. So this is the kinetic energy difference which is expressed as a work. So we can say if it is a work done, it should be done by a force, okay, on a body over a certain displacement. On a body, if force is applied, if you are pulling this object, the force is applied on a body, then definitely it gets displaced. Get my point? So that is what the work done. This is the correct definition for work done. We can involve this definition also. Okay, the change in kinetic energy of a particle is equal to the work done on it by the net force. That also we can take. So both the definitions are, I mean, it is true, and then you can write any definitions. Mainly, this kinetic energy difference is taken into account. So since it says this is work energy theorem, so work and energy, how it is related. So here it is given the difference in energy will be the work done, okay, by the net force. So what about this example 6.2? It is given. It is also directly deals with the above theorem, work energy theorem. It is well known that raindrop, it is very important also. A raindrop falls under the influence of the downward gravitational force. Okay, and the opposing resistive force. Okay, raindrop falling under the influence of the downward gravitational force and the upward resistive force. Okay, so there is two. Okay, the later is known to be proportional to the speed of the drop. Later means the upward resistive force is proportional to the speed of the drop. Okay, but is otherwise undetermined. Unless otherwise, it is undetermined. Consider a drop of mass 1 gram falling from a height 1 kilometer. 1 gram falling from a height 1 kilometer. That is the given thing. So it hits the ground with a speed of 50 meter per second. Okay. So what is the work done by the gravitational force? That is the first question. Then what is the work done by the unknown resistive force? Both the forces are there, right? So the change in kinetic energy of the drop. So gravitational force we are going to find. First of all, we know that the change in kinetic energy will be, what is the work done? The work done has to be like where the raindrop will be. So the raindrop's initial point. At the initial point, at the maximum height, this is the 1 kilometer distance from the ground to the sky. I mean, the sky we are taking from the clouds. Okay, this is the cloud distance. And then at the maximum height, the velocity will be zero. So initial velocity for the ground is zero. So if you take like that, what is the delta K or the difference in kinetic energy? Half mv square minus half mu square, u will be 0, so it is equal to 0. So only half mv square is there. The speed of a drop is given. So v square, 50 times 50. Okay. M will be 1 gram it is given. So if you convert that into, since it should follow SI units. So gram should be converted into kilogram. So 10 power minus 3 you can put. Then what is there? What is the resultant if you multiply everything? It will be 1.25 joules. Okay. So then what is this? Joules means what is this? This one is meter per second, the whole square. This one is gram means it is kilogram. So kilogram meter square per second square. So that is the energy, kinetic energy formula, kinetic energy unit of kinetic energy. So that is represented as joule. Okay. Then assuming that G is a constant. Okay. With the value of 9.8 meter per second square, but we can round off and then make it 10 meter per second square. So you know that this is actually left hand side, right? Delta K. Then in the right hand side, MA into S will be there. So instead of MA into S, they put M into A will be acceleration due to gravity here. So G, and then this S will be height, the displacement. Here, this is the displacement. So then you are just writing what is M 10 power minus 3 kilogram. This G will be 10 meter per second square. And then this height will be 1 kilometer. So in SI unit, meter is the unit. So kilometer should be converted into meter by multiplying 10 power 3. So the value will be 10 joule. Okay. So here it will be 1.2 joules. The difference in kinetic energy will be 1.2 joule. Okay. So where we can find, right, the work done by the resistive force on the raindrop will be 1.25 minus 10. Okay, this is the work done by the resistive force because you calculate first initially the work done by the raindrop and then next you found the work done due to, I mean, the not only the work done, we can write like this, work done by the gravitational force. There are two forces under the influence, the resistive force and the gravitational force. So work done by the gravitational force is 10 joule. Okay, so that is very high. Okay. And then what about the resistive force on the raindrop? It is opposite. Definitely it is opposite. It is 8.75 joule. Okay. So this problem is very important. You'll be asked this kind of problems. Okay. And then there are some examples also given. Vertical motion of object under gravity. This is an example, right? So let me dictate you something. Take a note of this. Okay. So consider a case of vertical motion. Consider a case of vertical motion. Okay. Of object under gravity. For object under gravity when the body is projected upward. Okay. When the body is projected upward. Okay. Write this example. When the body is projected upward, force of gravity is opposite to the direction of motion. Force of gravity is opposite to the direction of motion. The raindrop is hitting here and the gravity attracts like this. So it is opposite in motion. Okay. And then, and so kinetic energy of the body decreases. How about the kinetic energy? Definitely kinetic energy decreases. For decreasing, you can use this symbol. Okay. And when it falls downward. Okay. When it falls downward, the kinetic energy decreases. Keep in your mind. Okay. And when it falls, force of, okay. No. When the body is projected upwards, you can write like that. When the body is projected upwards, it is against the gravity, so the kinetic energy decreases. Okay. When the body is falls, when it falls downwards, it is downwards, then the kinetic energy increases. Okay. So this and all you need to understand. Okay. How it is increasing, how it is decreasing. Likewise, you'll be asked. Okay. So do copy in your notebook and then do copy another example also. When an object moves on a rough horizontal surface. This is horizontal surface. When an object moves on a rough horizontal surface, then friction force acts opposite to. Then the second example I gave you is when an object moves on a rough horizontal surface, okay, friction force acts opposite to the direction of motion. Which will act opposite to the direction of motion? Frictional force. So friction force act opposite to the direction of the motion. Take a note of all these things. Okay. Therefore, kinetic energy will decrease. In that case, kinetic energy will decrease. And decrease in kinetic energy, just take a note, and decrease in kinetic energy of an object is due to this frictional force which is opposing the motion of an object, the kinetic energy decreases. And the decrease in kinetic energy of an object is equal to the work done against the friction force. Work done against the friction force. So these two is an example. Based on this first example, gravitational force, right? The movement of an object against the gravitational force or towards the gravitational force, whatever it might be. So both cases can be discussed in the first example. In the second example, horizontal motion, which is affected, which is opposing the frictional force. Okay. So the frictional force is in the opposite direction during the horizontal motion of an object. So discussing about these two cases, you will be asked problems like the 6.2 based on the first example. Okay. So keep in your mind all these things. This is very important. And then I will explain you about the problem kind of questions regarding to this. I will give you two statements. Okay. Take a note of this statements. The statements are very important. Okay, what is that statement actually? Do write. Consider the following two statements. Consider the following two statements. Two statements. First statements are linear momentum of a system of particles is zero. Okay, first statement is linear momentum of a system of particles is zero. Okay. The second state, linear momentum of a system of a particle is zero. The second one is kinetic energy of a system of particles is zero. Kinetic energy of a system of particles is zero. Okay, here it is given a system of particles, not only the single particle,